All right, our topic today is solving exponential equations. Okay, so we're going to solve exponential equations, but we're going to try to do so without a calculator wherever possible. So what exactly is an exponential equation?
It has a constant base and a variable power.
Okay, so that's an exponential, but what makes it an exponential equation? So an exponential equation is an equation, has to be an equation containing a variable and an exponent. Remember we said before that x squared is an algebraic expression, whereas 2 to the x is exponential. You have the variable and the exponent. So some examples of an exponential equation are 2 to the 3x minus 8 is equal 16. 4 to the x is equal 15. 40 times e to the 0.6x is equal 240. So all of these would be exponential equations. Now, some exponentials equations can be solved by equating the basis. Equating the basis. So what that means is you want to rewrite the equation so that you express each side of the equation with the same base. So you want to rewrite your equation so that both sides of the equation have the same base. If we are able to do that, we may be able to solve the exponential equation without a calculator. What allows us to solve it is the fact, we talked about this before, is that exponential functions are one-to-one functions. What does it mean to be a one-to-one function? So one input goes to only one output. Okay, so that's how we define a function. What makes that function one-to-one? So since all exponential functions are one-to-one, again, so this means each input has one output, and each output value has only one input. So that is what makes it a one-to-one function. And I think the example we used to show that a function is not one-to-one was we said f of x is equal x squared, or y equals x squared. This is a function because every input value only goes to one output, but it is not one-to-one. And the reason it's not one-to-one is because both f of 2 and f of negative 2 are both equal to 4. So the output value of 4 actually maps to two input values, namely 2 and negative 2. So although this is a function, it's not a one-to-one function. Well, exponentials are one-to-one. So because of that, if b to the m is equal b to the n, because exponentials are one-to-one, then I know that m is equal to n. So if we are able to equate the bases, then all we need to do is solve the equation m equals n. And that will give us our solution. That way? Okay. Now, before we start solving these equations, we need to make sure that we recognize some of the I don't want to call them, I guess I'll call them basic powers. So let's take a look then at the 2's. All right, ladies and gentlemen, 2 to the first power, 2 to the second, 2 cubed, 2 to the fourth. I'm sorry, 2 to the fourth is 16. 2 to the fifth, 32. 2 to the sixth, 2 to the seventh, 128. 2 to the eighth, 256. 2 to the ninth, 512, and 2 to the 10th, 1024. 3 to the first, 3 squared, 9, 3 cubed, 27, 3 to the fourth, and 3 to the fifth. All right. 4 to the first, 4 squared, 4 cubed, 4 to the fourth, 256. I think we're okay there. 5 squared, 5 cubed, 5 to the fourth. All right. And last one, 6. 6 squared, 6 cubed, 6 cubed, 216. Can we do 6 to the fourth, or are we okay with 216?
No, 6 to the fourth.
6 to the fourth. All right, I'd be satisfied if you just do up to 6 to the third on that one. All right, so let's take a look. I think it would be wise for you to know as many of the powers of 2 at least up to 3 to the 5th, at least up to 4 to the 4th, at least up to 5 to the 4th, at least up to 6 to the 3rd. Okay, so I gave you an example earlier of 2 to the 3x minus 8 is equal 16. So now what we're going to do is we're going to try to solve this without using a calculator. What's x equal to? Well, one of the things that we can do is try to determine if we can rewrite both sides so that they have the same base. What I immediately recognize with the 16 is that 16 is 2 to the 4th. So we can rewrite this as 2 to the 3x minus 8 is equal to 2 to the 4th. Because exponentials are one-to-one functions, now I can set the exponents equal to each other. 3x minus 8 is equal 4, and now this becomes an Algebra 1 linear problem. Add 8, divide by 3, and you're going to get x is equal 12 divided by 3, x is 4. Now another example we had was 4 to the x is equal 15. Well, with this particular problem, there's really not any way for us to get equivalent bases. So we can't solve this one with today's lesson. We'll be able to do this one on Monday. But I do want you to know that you can determine where your answer lies. So you're saying 4 to some power is going to equal to 15. What I know is that 4 to the first is equal to 4. And 4 to the second power is equal to 16. 15 is in between 4 and 16. So I know my answer x will have to be between 1 and 2. Now 15 is a lot closer to 16 than it is to 4. So not only do I know that my answer will be between 1 and 2, I know it's going to be really close to 2. Now when we learn how to solve this on Monday, you're going to see that the answer is about 1.95. And that makes sense. Because again, 15 is a lot closer to 16 than it is to 4. Okay? So let's go ahead and take a look at a couple more examples. All right, so on the last example, we only had to change one side. Take a look at this example. So we have 27 to the x plus 3, and that's equal to 9 to the x minus 1. So here's a case where we should be able to equate the bases, but we will have to change both of these terms here. What I notice is that 27 is 3 to the third power, 9 is 3 to the second power. So 27, we can rewrite it as 3 to the third, and then that's raised to the x plus 3. 9, we can rewrite that as 3 squared, and that's raised to the x minus 1. Well, what do you do with your exponents when you have a power raised to a power? Put them in the front? You're thinking of logs. You're thinking of the power product of log, power property of logs. So here, you multiply the exponents. Remember, x to the a raised to the b is the same thing as x to the a times b, whereas x to the a times x to the b is x to the a plus b. So when you have a power raised to a power, you take the product of the exponents. So this becomes 3. Now I'm going to multiply 3 times x plus 3. And this first time I'm going to write it out because to remind us that you are going to have to distribute that. So this would be 3 to the 2 times x minus 1. So here, because your bases are the same, we can set the exponents equal. So you're going to get 3x plus 9 equals 2x minus 2. So again, 3 to the third raised to the x plus 3 would be 3 to the 3x plus 9. That 3 has to be distributed there. Again, now this is an algebra 1 problem, solve a linear equation. Subtract 2x. X plus 9 is equal negative 2. Subtract 9. And you're going to get x is equal negative 11. So that's our solution there. Any questions? Okay.
So you're just, since the bases are the same, you're just basically evaluating, like putting the exponents to it? Like
Yeah, because they're 1 to 1. So remember, logs and log is an exponent. Logs and exponentials are 1 to 1. So if you can get the bases the same, you can go ahead and equate the exponents. Now here's another example. Take a look at this one. All right, ladies and gentlemen, how about this problem? Can we solve this one without a calculator? 6 to the 2x plus 3 is equal to 1 over the square root of 6. Is there any way we can equate the bases here?
Yes. 6 to the 1/3.
All right, so here's our bases are both 6. But remember that the square root of 6 is the same thing rationally as 6 to the 1/2 power. So 1 over the square root of 6 would be 1 over 6 to the 1/2 would be 6 to the negative 1/2 power. So now you have 6 to the 2x plus 3 is equal to 6 to the negative 1/2. Fractions are numbers also. So we can solve this. They're numbers. So how do we solve this?
We divide by 2. We subtract 3.
Subtract 3. So 2x is equal to negative 1/2 minus 3. So what is negative 1/2 minus 3? So negative 1 over 2 minus 6 over 2? Negative 7 over 2? So 2x is equal to negative 7 over 2. You will leave it in fraction form. Remember, no calculators. I don't want decimals. Final step, divide by 2. So x is equal to negative 7 over 4. Now, I'm going to show you something. All right, we're going to take a different approach with this same linear equation. Okay, so negative 7 divided by 2 divided by 2. Division is just multiplying by the reciprocal, so this is negative 7 over 2 times 1 over 2. Because remember, this 2 is the same thing as 2 over 1. Okay, but I'm going to take a look at this another way. So 2x plus 3 is equal to negative 1/2. I don't like fractions. So if there's some kind of way I can rewrite this so I don't have a fraction, I probably would be a lot happier. So here, I take a look at my denominator, it's a 2. So what I'm going to do is something called clear the fraction. So I'm going to multiply this entire equation by 2. The entire equation, everything gets multiplied by 2. So everything is now going to become a multiple of 2. 2 times 2x is 4x. plus 2 times 3 is 6 equals. Now 2 times negative 1/2 becomes negative 1. Now I no longer have a fraction. Now you have to, I know you guys have done this before in Algebra 2 and Algebra 1, clearing the fraction.
But I don't mind the fraction.
Yeah, and again, fractions are just numbers. So subtract 6, 4x is equal to negative 7, and divide by 4.
Oh my goodness. Mr. Brown, why you never tell us this?
I'm assuming that you guys have already done this. Excuse me.
You're keeping these secrets from us.
No secrets. All right, so ladies and gentlemen, you have the rest of the time to work on the assignment.